In this video, I'm going to go through our second lesson on solving a quadratic with the quadratic formula. And the quadratic equation is going to look like this: a number in front of your x squared term, and then you have a linear term and then a constant term. And so something like this that you see here in this example. And the first thing I want to do is refresh your memory to a video that we had for the first lesson, and that is when your discriminant is a perfect square. This is how you know you can factor. And so with the question here that it says, can you solve by factoring, we can just kind of think through it, and then I'll show you with the discriminant piece. So I have taught my students that what we do is we take a times c at the top of a big X. I just kind of write a big X down. And then b for your term goes at the bottom. And if my a is 1 and my c is -3, and my middle number is -3. My goal is to think of two numbers that multiply to make -3 and also add to make -3. And I just cannot think of anything, because even if I had -3 and 1, they will not add to make -3. So this is impossible. And so no numbers multiply to -3 and add to -3, but also with the discriminant, which is the b squared minus 4ac. If this is a perfect square, then you can factor. And our b here is -3, so I'm going to take -3 and square it, and then I'm going to subtract 4 times my a of 1 times my c that's -3. -3 times -3 is 9. And 4 times -3 is -12, and 9 plus 12 is 21. 21 is not a perfect square, so that also means it is not factorable. So there's two different ways you can decide. You can actually try to factor it, or you can just look at the discriminant. And now what I'm going to do is show you 4 examples of solving a quadratic with the quadratic formula. And remember, just kind of as an important step, remember, always write your equation in standard form first if it's not. You have to have your equation set equal to 0. Otherwise, you're probably going to get one of your a, b, and c's as the wrong number or sign, and then that's going to just mess everything up. And so I just wanted to kind of highlight that as well. Okay, so here we go. My first equation here, my a is 1, my b is 6, and my c is -16. And I like to start with the discriminant piece first. That just makes it slightly easier for me. So my b squared minus 4ac, I'm going to take 6 squared and then subtract 4 times 1 times -16. Let me grab my calculator here. 6 squared is 36. We're going to be subtracting a negative because this is a negative symbol here. So 4 times 1 times 16, 64. And when I add those together, I get 100, which tells me that I could factor. So I'm going to first do the quadratic formula, and then I'll check my work with my factoring. And so if I start with my formula here, x equals opposite of my b, so -6, because opposite of positive is negative, plus and minus the square root of that number we just found, 100, all divided by 2a. 2 times 1 is 2. And now let's simplify. This would be the same as -6 plus and minus 10, because the square root of 100 is 10, and then we will divide by 2. Let me move my camera just slightly down here to give myself some more room. So now my two solutions are going to come from when I add and when I subtract. So -6 plus 10, and we'll divide by 2, and -6 minus 10, and we'll divide by 2. So this is going to be 4 divided by 2, and then -16 divided by 2. And so since I got nice whole numbers, we could have factored, and I'll show you that. What two numbers multiply to make -16 and add to make 6? A +8 and a -2. And you might be thinking, well, how did you get -8 then? And I'll explain here. you set your factors equal to 0 and then you solve, which is why when you subtract 8, you get -8. And then if I set this factor equal to 0, I'm going to add 2 over, which is why I get -2. So your factors and the sign of your solutions will always have opposite signs, so +2 and -8. I'll do a couple more examples in this video. Again, you have to have your equation set equal to 0, so I'm going to add 3 to the other side so that my function is set equal to 0. So I'll have x squared minus 2x and plus 3. So a is 1, b is -2, and c is 3. And I'm going to find my discriminant piece first. So -2 squared, and then we'll subtract 4 times a of 1 times c of 3. This is going to be 4 minus 12, which is going to get us -8. And our quadratic formula here is going to be opposite of -2, which is +2, plus and minus the square root of -8, all over double my a term, or double 1, which is 2. Now, if you type in the square root of -8, you're going to get an error on your calculator, which means that this will have no real solutions. And so that is my answer, because you cannot have a negative under your radical sign and get a real solution. So we'll just stop here and say no real solutions. All right, I'll do 2 more examples here. And again, you have to have your function set equal to 0. And so what I'm going to do first is subtract 4, and then I'm going to reorder because I notice I don't have my square term first. So I need to have my square term in the front. So this would be 4x squared, a -6x term, and then I subtracted 4. Now that we have set equal to 0, I can identify my a and b and c. A is the number in front of your square term, b is in front of your linear term, and c is your constant term, the number term with no letters. And so here we go. I'm going to start with my discriminant, my b squared, which is -6 squared, and then I'll subtract 4 times my a of 4 times my c of -4. And this is going to be 36, because a negative times a negative makes a positive, and we're going to subtract a negative here. 4 times 4 times 4 is 64, and when I subtract a negative here, it'll be 36 plus 64, which is 100. I know that because we did that on the other side. So now x, my solution, my x-intercept will be opposite of b, or 6, plus and minus the square root of 100, all over double my front term, which is 8. Now this looks super familiar. Doesn't it look like one that we did on the other page? Oh, okay, here. We had a 6 and 100, but the bottom number wasn't 2. We didn't have an a of 1. So it's close, but not quite the same. And I know the square root of 100 is the number 10. And now I'm going to have my 2 solutions, one when I add and one when I subtract. 6 plus 10, and then we'll divide by 8. And 6 minus 10, and then we'll divide by 8. This will be 16 divided by 8, which will give me an answer of 2. And then 6 minus 10 is -4 divided by 8. If I simplify that, that's going to be a half, a -1/2. All right, we have one more left. And again, you have to have set equal to 0 first. So I'm going to add my 14x over here. So I have 2x squared plus a 14x and plus 23 set equal to 0. My a is the 2, b is 14, and c is 23. And I like to find my discriminant first. So that's going to be 14 squared minus 4 times 2 times 23. And 14 squared is 196. And we'll subtract 4 times 2 times 23. On my calculator is 184. And 196 minus 184 is 12. So x equals opposite of b. So opposite of 14 would be -14, plus and minus the square root of 12, all over double my a. Double 2 would be 4. And now I'm going to get a decimal for my square root of 12. So this is going to be the decimal, here we go, 3.46. and then we'll divide by 4. So again, we want one answer for when we add and one for when we subtract. Oops, 3, not 13. And now subtract. And I'm just going to use my calculator for this. So negative 14 plus 3.46, I'm going to get an answer, and now divide by 4. And I get negative 2.6. I'm going to round this up to 4. And then for my next one, negative 14 minus 3.46. And then I will divide by 4. And I get negative 4.3. And again, this 6 is going to round up to a 7 because that 5 is going to round your 6 up. And those are our two answers. Notice that there are some partner practice problems. I'm not going to record a video for this, but check my Canvas page for the answer key.